Hello, everybody, and thank you for joining us in our panel today. My name is Steve Schultz. I'm one of the session chairs, along with John Bank, and we welcome you to our session on how Agile manufacturing is helping small and medium manufacturers become resilient. I have a few housekeeping items to discuss, and then we'll get started. First of all, I'd like to thank all the sponsors for making this event possible, especially DTE and co-sponsor. Please click on the sponsor link on the left-hand column of your page and visit their sites to learn more about the work. We have an exciting lineup of speakers. After the three presentations are given this afternoon, we will have 15 minutes after the session for questions and answers. AC typically will collect any remaining unanswered questions and send them to the speakers to respond directly to after the conference. With this in mind, you can see the chat box on the right-hand side of the screen. Please use this box only to ask questions of the speakers and engage in dialogue with other attendees. I would be monitoring the chat box to identify hidden questions that we have not answered. If you'd like to connect with other attendees, please take advantage of the attendee link also found on the left-hand side of your page and the attendee who has created a group map. In that column, you will find attendees. Program She has a doctorate degree and specializes in human scientific research, including surveys, experiments, and field cases. At Northwell, she focuses on how movement and improve so let's look at the Checking the sound. So now the sound is great. Can I get one more acknowledgement of that? Okay, let me start over. I'd like to thank everybody for joining our session today. I think we have a very good lineup of speakers. Our panel is entitled How Agile Manufacturing is Helping Small and Medium Manufacturers Become Resilient. So we have some housekeeping items to go over. And since I did the first part where you couldn't hear me, I'll have to go through this a little bit more quickly. First of all, I'd like to thank all the sponsors for making this event possible, especially DTE Energy, the host sponsor. Click on the sponsor link on the left-hand column of your page and visit their site to learn more about their work. We have an exciting lineup of speakers. We have 3 presentations, after which there will be time for questions and answers. There will be a chat on the right-hand side of your screen that you can post questions. I'd like to encourage you to post questions, but refrain from dialogue among other attendees on this side of the chat, because I will be looking for the questions and trying to identify those that we want to bring forward during the question and answer period after the 3 speakers. You will also find an attendee link on the left-hand column of your page. Any attendee who has created a profile can be found there. You'll also find resources for you attendees. It'll include the conference proceedings, an attendee list, and an evaluation survey to complete at the end of the conference. Anybody who completes the survey and includes their name and a testimonial will get a discount to the 2023 summer study. In the program participants link, you will find information about all the presenters, including bios and copies of their presentations. Lastly, please join us at the end of the day for post-panel debrief and questions and answers, and be able to meet other people that you may have not been able to meet so far during the conference. All sessions will be recorded, and on demand will be available after the conference. So now let's get started. Our first speaker is Dr. Joy Pixley. She is the Research Director of the California Plug Load Research Center at the University of California, Irvine. She has a doctoral degree in sociology from Cornell and specializes in human subjects research methods, including surveys, experiments, and field tests. At CalPlug, she focuses on how user behavior affects the energy efficiency of plug load devices and how to improve efficiency through better design, feedback, interventions, and control solutions. So Joy, please proceed with your presentation. Thank you.
Okay, can you see my screen? I hope. Excellent. Yes, wonderful. Thank you very much for that introduction. I will be talking today about this work that we did at the University of California, Irvine about small and medium manufacturers and helping them to adopt smart manufacturing. So let me start off, since I'm the first person to speak here, about why are we even paying so much attention to small and medium manufacturers. Now, we're talking primarily here, the definition that I'm going to be using at least is any company that has fewer than 500 workers. And although it makes sense for us to spend a lot of time talking about large manufacturers, because if you can make a change there, you can have a huge impact, 98.5% of all manufacturers are small and medium. And 44% of those have fewer than 5 workers in them. Now, an individual large employer may employ a lot more people, but small and medium manufacturers put together employ 44% of all manufacturing workers. And they create almost twice as many net new jobs per year, 8.4 million. So we have a lot of reasons why we want to make sure that these small and medium manufacturers succeed. And part of the problem here is that half of all new businesses fail in the first 5 years. And we have a lot of failure points here. So that's why we want to support small and medium manufacturers. And let me turn now to smart manufacturing. I can get this to work. There we go. So what is smart manufacturing? That's a really good question. My primary research in energy efficiency is in the commercial and residential sector. So when I got this project and I started doing this incredible lit review on what are people talking about with smart manufacturing, I was really overwhelmed, first off, by how enthusiastic people were about the promise of smart manufacturing to solve so many problems and to make people make companies so efficient. But I was also overwhelmed by the number of different ways that people talked about it. This Industry 4.0, it's the fourth industrial revolution. I really started thinking that if I had 10 experts in a room and I asked them, I would end up with at least 20 different definitions for what smart manufacturing was. So I got a whole bunch of experts in the room, and we came up with one definition that we could all agree on that we could present to the subjects. And the idea here, let me just break this down for you, is that smart manufacturing integrates technologies. So it's not just one technology, it's the integration of a whole system to communicate data between people and machines. So that's both people to people, machine to machine, person to machine, machine to person. It's all about trying to get information from one place to the other, but not just in a general sense. We want to make sure that it's going where it's useful, like to the right person right away. When it's useful, so we're not waiting until a month later to tell you that this thing has been inefficient the entire time, and in the form that's useful. So we're looking for actionable information that really helps people make decisions as effectively as possible. And the promise here is that we have an incredibly powerful tool to reduce all kinds of waste stream problems, productivity problems, increase efficiency, and increase competitiveness. And so the idea is not necessarily focused on energy efficiency, but by reducing all these other waste forms, we do in fact end up increasing energy efficiency. So that's great. Why don't we go ahead and just institute that for all of our small and medium manufacturers? Well, there's a lot of focus has been on the larger manufacturers, and people are really conscious of the fact that small and medium manufacturers face higher barriers. They have fewer resources, less flexibility. They might not have the infrastructure in place. They might not have the training for their workers. And when we did, again, the background research for this, we found a lot of people talking about the problems of small and medium manufacturers, but there's a lot less research out there than we really wanted. So we were looking for small and medium manufacturers, smart manufacturing techniques in the US. And we found SMMs, and we found small and medium in large, and we found SMMs and small manufacturing in Europe, but relatively little that had been done here in the United States. And so this project is part of a larger project looking at how can we more effectively approach this topic, the smart connected workers in advanced manufacturing. We did a survey. We worked with the NIST's MEP centers. The recruitment didn't work out quite the way we wanted it to. We ended up with 54 owners and employees of small and medium manufacturers, defined as less than 500. We also had a separate subsample that were consultants of SMMs. That's a whole different research project right there. And we focused on, first off, the questions that we pulled from other surveys about readiness drivers, barriers, pros and cons, in order to be as comparable as possible to those prior studies. And then we also wanted to focus on what specific tasks were these companies needing to improve upon, and what specific technologies were they using or could they be using? So let me jump straight into some of our results. The first thing to look at is readiness. And readiness with any of these innovations is often couched in terms of how ready is the management? Do they have a clear concept? Do they understand the technology? Are they willing to implement it? Are they willing to take risks? So these first 7 items are make up this readiness index that we pulled from another study. And we can see that the readiness index score on average is 3.8. It's just under that we somewhat agree that that these statements are true for our company. So that's pretty good. I mean, there's some room for improvement, but it's pretty good. And then we added some other questions about the employees being ready, the company having the economic freedom, and we see the lowest rate for the company already using smart manufacturing. So not so bad. It could be better. I want to point out that that readiness index was much lower in the study that we pulled the questions from. So at least we're doing better than, I think it was 2.9 for that one. Another aspect of readiness is how far have you already gotten in your implementation? And now we're starting to not look very good at all. So we only have 16% of the respondents saying that they're full concept in implementation. Another 20% are at least they've implemented first measures, but the majority have not even done that. We have a third of them saying they developed a clear business case, but it's not clear how quickly they're going to go from clear business case into first measures, and a full 12% are not prepared at all. And one of the things that helps you get prepared is whether or not the workers that you currently have are going to be able to adapt to these new technologies, and only 11% are saying that they have the skills. 63% saying that we would need more training. Now, some workers are going to be excited by that. Great, I can have on-the-job training, and some are going to really push back against that. And again, we have 1 in 4 saying we would need to hire new people, and that's obviously another sort of problem. Another issue that we thought would be important, and this was pulled from a survey that was looking at service sector, not an industrial sector, but the idea is, let's not fix it if it's not broken. What kinds of tasks are you doing where you're already using smart solutions, you think you would benefit from smart solutions, or no, it's okay, the traditional lower tech solutions are working perfectly fine. So I've sorted this by that red, by the idea that the lower tech is fine. And we can see at the top there that assigning jobs and tasks, communicating with third parties, and internal communication, all things involving people-to-people communication, are all, all of these things have some percentage of people saying, yes, it would benefit or already using, but these have the highest numbers of people saying, no, lower tech looks fine, let's not bother with that. Looking down at the bottom though, we see that the ones that are most likely that we could use smart solutions for is all about the data, inputting information into forms, analyzing data, and accessing data or information about our tasks. So that's what we're looking for. Another way of looking at this is what the waste streams are, like what productivity problems are you having that would potentially be solved with smart manufacturing solutions. And the green bar there is we always are often having this problem, and the orange bar is often, always, often, or sometimes. And the top two there we see are having to do tasks manually and having to wait for job and task information. And we see that that dovetails very nicely with what we just saw in the previous graph, because they were saying that those would be the best things for smart solutions, is getting rid of this problem with waiting for tasks, waiting for task informations or having to do them manually. We're looking next at the drivers and barriers. So first off, what are the most critical factors? The orange bar is if you said in your top three, and then if you said more than one, we then said, well, what's the topmost? And that's the green bar right there. And we see that the top two by far are reducing costs, which makes sense, and also conscious strategy on smart manufacturing. And this harkens back to that whole management readiness issue. Do we have a clear plan? Do we have a procedure and a strategy in place? And that's going to drive us forward when the going gets rough. When we're looking instead at the critical barriers, we can see that the top two problems are the additional investment of time and the additional investment of funds. Now, this is not surprising to us, but it's always good to quantify exactly how much of a problem these are to these companies. I also wanted to point out some of these that have very high in the top three that didn't necessarily make it to the top one. For instance, data security, implications on profits. The availability of equipment or software is more about, like, we don't have Wi-Fi, for instance, so we can't use that. And then we get down to the lack of qualified employees. So a lot of barriers that they are facing. I said before that we were looking at specific technology types. So we came up with this list of 20. We had, again, this great team of all of these different experts on this topic. And we pulled together this list of 20. I've sorted it so that it makes sense. It was randomized in the survey, don't worry. But the first ones are things that are hopefully more accessible to people, right? Tablets, mobile phones, handheld scanners, wearable scanners. These are things that you might even have used yourself. Wearable phones. Then we start getting into things that you wear, like smart glasses and various kinds of headsets and AR for training and purposes other than training. We had a hard time trying to figure out how to separate out Internet of Things and sensors and machine to machine, so we just put those all in one category. And then we get into a lot of IT issues, like cloud computing, cybersecurity, big data analysis and simulation, and then some things that are more focused on certain kinds of manufacturing, like artificial intelligence, autonomous robots, RFID and RTLS, additive manufacturing, which I didn't realize is what we called 3D printing until I got into this topic, and then horizontal and vertical system integration. Now, for each one of these, we asked, does your company use this as part of a smart manufacturing solution? So not just do you have cell phones, but do you use it as part of a smart manufacturing solution? If you say no, we ask, did your company ever implement it, but then later discontinue the use because you experienced problems? Or did you at least consider implementing it, but didn't because you thought you would have problems? And so then I took out the people who said don't know. There were a few of those. And I ended up with what was almost the most exciting thing to me, or most interesting thing, all the people who said no to all of those things. And I sorted it by that. That's the purple bar on the side there. And this tells me all of the technologies that are not even on the radar of these small and medium manufacturers. And what we see down at the bottom with the higher numbers is these are, in some cases, some of the big, exciting, sexy things that we're talking about for larger manufacturers, just not cutting it with the smaller ones. So I've bolded here, these are the top 5 that are currently in use: tablets, cybersecurity, mobile phones, big data analysis, and IoT sensors. Those are all 50% or a little bit over 50% of the people are saying that this is being used in their company. Like I said, we also asked, did you try it but discontinue it? I've bolded all of the ones that are, over 5% of our people said that this was true. We did ask a follow-up question asking, why did you discontinue it? But it's such a small sample size that we can't really explore that. I would love to do that in future research. Same thing with here, that you considered it but rejected it. Would love to know why you rejected it, but that's a great source for the next study, I think. For each of the technology types, we also asked them what the main pro and the main con were among this group. So here, let me explain a little bit about what you're looking at. So the very right side is the overall average across all the technology types, and then we start with the most used cybersecurity, and it goes down to the least used, the smallest percentage, and then looking at which things were most often mentioned as the significant pro. We see increased task completion speed, highest overall and much higher for many of these technology types, particularly the ones that are most used, which are on the right side there. We do have better ergonomics coming up for a couple of these as being more important than others, and less so for the task complexity and the easier implementation and the management by walking around, which I would love to talk about. But when we look at the cons, we see a lot less agreement. First off, we don't see one thing that comes out as being the major problem for all of the technologies or most of them. And we also see a lot of disagreement among our respondents about what is the worst con for any given technology. So cost comes up as being a substantially higher problem for a couple of these things, like smart glasses and robots and AI and handheld scanners. But the other ones are generally not coming up quite as often, a little bit on privacy and security threats. So I don't know if what this means is that all of these things are equally problematic. Maybe all of these things are equally not problematic, and I don't really even have the main con on there, or if this is really the case that different people in different manufacturing situations, for instance, have different negative experiences. And this is the final graph that I'll show you. And this is for companies that are using this technology. How did most workers in your company react to implementing it? And I have bolded, again, the top 5 that are in use. And we see that dark green bar is the strongly positive. And at least the ones that are most in use have pretty strongly positive responses. So less so for IoT, and it's interesting. If we look at the dark green and the light green put together, we see that we have a lot of positive responses overall. But let's look at it from the other direction. Looking from the negative side, first off, we see that one black line for autonomous robots. I would really love to know what happened with those autonomous robots, because we have 13% of our people saying strongly negative response to that. And if we add that all up, the strongly negative, somewhat negative, and mixed or neutral, we have 20 to 40% of not positive for a lot of these technologies. And it's very important that you have worker buy-in. So this is potentially a problem. Okay, so overall, what are the takeaways here? Well, I think we can say that smart manufacturing is an incredibly powerful thing. If small and medium manufacturers in this country are going to become more productive and more efficient and more competitive, they're going to need smart manufacturing. It's going to be an important part of this. And they're going to need some help with some innovation, how we're going to get them to resolve the different challenges that they face. So on the one hand, negotiating cost and time. They're telling us that, well, what would drive us is that we could save a lot of money with these solutions, and we're going to have like this really good conscious strategy toward it, but we don't have the money to invest to save money later, and we don't have the time to invest to do the research to come up with the development, to come up with the strategy. So they're caught in this cycle, and they could probably use some help with that. They have relatively limited readiness at this point, both in terms of how much they have gotten done so far and how much they would have to train or even hire new workers. Hiring new workers, 1 in 4, that's going to be prohibitive for a lot of these companies. And then we're looking at the worker response, and we're getting, like I said, 20 to 40% not positive response to some of these technologies. Okay, so what does this tell us? What can we do next about this? And I think that what this is telling us is that we really want to focus on tailored solutions that are tailored to small and medium manufacturers. So on the one hand, looking at what problems they want to solve primarily data problems, inputting data and getting data back on information. That we want to talk about the pros and the cons that they have across these specific technologies, learning more. I think this is a great first step, but let's learn more about exactly what they're doing. And I think it's important to look at what inroads they currently have, that they are using things that are fairly accessible options. Tablets and mobile phones, we all have those. Cybersecurity and data analysis they're probably doing in most cases anyway. And IoT is something that I think a lot of people can at least conceptualize. So the idea is there's a lot of attention to these big, sexy, cool, huge things that we're doing for large companies. Should we try to make those more palatable for the smaller companies, or should we try to start where they are and start with those smaller things and the sort of medium level things? Scale down these solutions, make them approachable and easier to implement and less expensive, so that they require less infrastructure, they require less specialized training, and that's going to help us to give them options that will deal with some of those challenges they're facing. And so the idea is that we are supporting these companies to start small and build their way up and have a smart approach to their own smart solutions. There we go. And I'm going to stop sharing with that. Thank you.
Well, thank you, Joy. I think that was a perfect kickoff for our session on agile manufacturing and how small and medium manufacturers are sometimes struggling to implement it. I think it's very, very important, and I think COVID probably has taught us a lot about needing to be agile, as supply chains certainly took a stress test during the COVID crisis, and in many cases are still being affected by it. Thank you very much for that presentation. It was really right on track for what we wanted. Our next speaker is Vestal Teterow. Vestal is a program manager at Lawrence Berkeley National Laboratory. He has an extensive background in energy management and energy efficiency in both the industrial and commercial sectors. Vestal has a bachelor's in mechanical engineering and materials science from Duke University, a master's in systems management from the University of Southern California, and a sustainability-focused executive master's in natural resources from Virginia Tech. He is a registered professional engineer, a certified energy manager, a certified practitioner in energy management systems, and a certified international sustainability consultant. In Vestal's presentation on energy management and a product sustainability standards, a key link to sustainable supply chains is next. Thank you, Vestal.
Hello, everyone. I'm excited to be here today as part of the Summer Study in Industry. It's always been one of my favorite conferences to attend, just because of the diversity of attendees and the levels of expertise. So it's always great to be here. Of course, the flip side of that is when I'm presenting, there's always a number of people in the audience who know more about a given topic than I do. So I'm sure that's the case today. And if you have comments, feedback on what you hear from me today, I do welcome your feedback. I want to acknowledge my co-author, Ethan Rogers of the Department of Energy, and also say thanks to Erica Logan of the Global Electronics Council, who provided input and review. So here's an overview of my presentation. So this paper is a result of Ethan's and my participation as representatives of the Department of Energy in the development of new and the revision of existing electronic product sustainability standards. Our efforts build on prior contributions of others before us, especially Paul Shine, who's now retired from the Department of Energy, but is still active in this area. So we participated in ad hoc groups that were focused specifically on energy management systems. We didn't get involved in other sustainability topics such as responsible minerals, product packaging, reuse and recycling, or corporate practices. So there were other experts and other expert ad hoc groups addressing those topics. And these efforts were largely led by the Global Electronics Council, formerly known as the Green Electronics Council. So electronic products from cell phones to servers have become ubiquitous globally. As the number and types of electronic products grow, so does energy and carbon footprint of the electronics sector. For perspective, at over 800 terawatt hours per year, the sector uses more electricity than all but 5 countries annually: US, China, India, Russia, and Japan. Another important factor, which you'll hear more about, is supply chains are vital in the electronics sector, accounting for 77% of the sector's greenhouse gas emissions. So this graphic shows, from the Global Electronics Council, shows the life cycle carbon footprint of a product. And that second graphic from the left, part of the upstream carbon, represents typically what is produced by a supply chain. So much of the carbon footprint of a product is on that left side of this graphic, particularly on the supply chains. So what are some of the benefits of having electronic products sustainability standards? So for manufacturers, it provides a consistent set of actions that they can take to make a product more sustainable. It can provide incentives for manufacturers to improve the sustainability of their operations, especially for suppliers. And if they're early adopters, they can provide a market advantage to them. So for purchasers, it provides the basis for measuring the sustainability of a product, including energy. You can compare between products and at least make an informed choice. Policymakers see benefits through these standards also. They can be easier to develop and implement than regulations. It provides opportunity to learn and be educated about the perspectives of other stakeholders involved in the development of these standards, and can create market demand. Also, they could be adopted into regulations at the state or federal level. So this is just an example of how the development process for a standard works. Of course, it varies by product and based on the standards development organization that's leading the effort. Typically, they're convened by a standards development organization or criteria development organization. Identify the stakeholders and get them organized. And it's very important to make sure there's representation from all interested stakeholders too. So they break into working groups to develop individual criteria once there's once the goals and objectives are shared. Put together draft criteria, come back together as a larger group, work out the details, hash things out, develop a consensus, ideally, which would result in a vote on a final standard. So typical development organizations might include Underwriters Laboratory, IEEE, NSF International, and there's a German organization called TÜV Rheinland also in this space. Some examples of stakeholders: manufacturers, suppliers, recyclers, government entities, and others that you see listed there, especially nonprofit groups. So exactly what gets published in a sustainability standard depends on some of the factors you see here, such as what can be agreed upon within a reasonable time frame, and stakeholder priorities, because these are consensus standards. This graphic, courtesy of EPA, shows another way to look at a generalized life cycle for a product and its components, from materials extraction through the manufacturing process, distribution, usage to its end of life. This is similar to the graphic a couple slides earlier, but this is sort of a circular economy perspective. For electronics products, the Global Electronics Council has been a big advocate and leader in sustainability standards. They created the EPEAT registry. EPEAT stands for Electronic Products Environmental Assessment Tool. This registry is a database of products that meet the criteria contained in the standards. They currently have standards for the items shown on the right side of the screen here, 7 different eco-labels. So each product receives an EPEAT eco-label, and it could be bronze, silver, or gold, depending on the number of optional criteria that the product meets. And some of the criteria include, minimizing electronic waste, reducing the amounts of toxic materials, doing life cycle assessments, corporate reporting, and other areas. And more recently, energy management, which is what we'll be talking a bit more about here. So research has shown that for many electronics products, most of the life cycle energy consumed and most of the emissions from a product is in the manufacturer of that product. So using an iPhone, the Apple iPhone 12 as an example, this chart is from Apple. 83% of the life cycle emissions of the phone occurs during the manufacture of the phone. So in the electronics sector, many OEM plants are for assembly only. So therefore, if you want to go after the emissions reductions, you need to look at the supply chain. And many of these suppliers are small and medium-sized enterprises that may have a limited awareness of the opportunities for energy savings or limited emission incentives to improve. So changing gears a bit, what is an energy management system? As mentioned earlier, the Department of Energy's efforts have been to incorporate criteria on energy management systems in these standards. I won't get into too much detail on energy management systems, assuming that most of you are familiar with the concept, whether through the international ISO 50001 standard, or perhaps through the strategic energy management initiatives. But just quickly, the standard's rooted in the Plan, Do, Check, Act concept developed by W. Edwards Deming, and which in turn was based largely on the scientific method. So the ISO standard created basically a framework that organizations can use to develop and implement an energy management system. And the goal is for it to become an integral part of business practices. So how are we going about incorporating energy management systems criteria into the sustainability standards? So this shows a typical approach that the Department of Energy has been promoting based around the 50,001 standard. So there's levels. We've suggested a 50,001 self-declaration with Department of Energy's 50,001 Ready program as a ready-made path to help making that happen. ISO 50001 third-party certification, as well as Department of Energy's Superior Energy Performance program, which is basically ISO 50001 plus with some additional requirements and the requirement to show improvement. Okay, this table lists the 7 products that have the existing standards, along with the name of each standard, the date of publication, and the right column shows whether there's energy management criteria currently existing. So you'll see that 3 of the 4 standards have energy management criteria applied. And also note that, you can see I mentioned UL, IEEE. So these are the organizations that have developed their standards here with the standard name. So to dig a little deeper into this, here's the basic energy management system criteria for some of the standards. Note that 2 include self-declaration. All 3 include the superior energy performance. 1 includes the Energy Star guidelines for energy management and the Energy Star Challenge for Industry Certificate of Achievement. And then 1 is a little bit different, and it has specific defined performance improvement criteria that must be met over certain periods of time. All these criteria are generally optional. Companies receive points or credits for meeting certain criteria. For example, for the servers, a supplier gets a half a credit for doing the self-declaration, 1 credit if they do third-party ISO 50001. And if they are recognized under superior energy performance, they would receive 2 credits. And this is what I've written here is shorthand. So since these are international standards, typically what the wording in the standards say, national equivalent. So that's pretty standard. That it would something that meets the similar requirements to superior energy performance or to self-declaration. So more credits depending on the stringency, and these credits add up to points. For example, an OEM would get 1 point if they have 10 supplier credits total. They would get 2 points for 20 supplier credits, and 2 being the max that they could get. Not included here, there are verification requirements that are also spelled out for the criteria. All right, so in 2019 and 2020, there was work led by Global Electronics Council on a common criteria that would cover carbon emissions, end-of-life management, a lot of these areas that you see listed at the bottom. Unfortunately, that effort stalled out last year, but recently the Global Electronics Council began a new effort, which we hope will be completed sometime in 2022. But they're working on what's called a dynamic criteria development process with developing modules under 4 areas. One of the areas is climate change mitigation. And within that is an energy management ad hoc group, which Ethan and I are participating in. So the goal is to create something that can be harmonizing and consistent, that could be adopted into standards in the future as they are maintained and revised. In the few minutes I have left, I wanted to move on to talk about beyond the electronics sector. So based on a non-exhaustive search and review of sustainability-related initiatives in other manufacturing sectors, I found that many do include supply chains. Some mention energy, some mention implementation of management systems, especially environmental management systems, but none really mention or call out energy management systems. To dig a little deeper, I saw the sustainability initiatives that you see listed here for chemicals, aluminum, steel, forest products, pharmaceuticals, and aerospace. Yeah, a lot of these had an emphasis on the environment through energy management, environmental management systems, that is, standards and management practices. Some cross-cutting initiatives are shown here. And 3 of these happen to be specifically supply chain focused. As I mentioned, many of these initiatives outside the electronic sector include a focus on management systems and supply chain engagement with the limited, however, emphasis on energy efficiency or energy management. And based on the fact that, over 80% of the embodied energy typically occurs prior to arrival at the final assembly plant, there's great value in further engaging supply chains on energy management, especially since the UN Global Compact participants rank supply chain practices as their biggest challenge for improving sustainability performance. And according to the CDP, the average company supply chain emissions are around 11.4 times greater than direct. So given these specific and cross-cutting initiatives and our experience in the sector, I think there's opportunities to embed energy management into other sectors within manufacturing through these initiatives, either through voluntary sustainability standards, rigorous guidance, or maybe other methods that may work for that particular sector. In conclusion, Department of Energy representatives have participated in the development and or revision of several standards, helping draft energy management systems criteria to embed into the standard. This work continues to create modules, to create some consistency between the standards. So a few years ago, I did a sustainability-focused executive master's program. One topic that has stayed with me is something called collective impact, where a group of stakeholders come together with a shared vision and goals, shared ways to measure and collect data. And they also have a strong, what they call a backbone organization to carry forward the initiative. So for the electronics sector, the sustainability standards development process, I think, effectively functions as a collective impact activity, with the Global Electronics Council being the backbone. So I think perhaps this could be replicated elsewhere within the manufacturing sector. And this is where I would welcome your feedback. Is this already happening and I missed it? If not, welcome your ideas on how we could work and make it happen. And questions will be saved for later. And my contact information is there. So back to you, Steve.
Thank you, Vestal. That was very interesting. It's very dynamic how much the supply chain impacts our environment and how much energy is required in our supply chain. And it's a difficult thing to try and get a handle on. The supplier has to know who the supplier is in some cases, and that can get quite a ways upstream. And as some of these suppliers are small and perhaps small, and energy might not be their highest priority, it might be difficult to get to influence them. So thank you very much. I'd like to encourage people to add questions to the chat. We will be having a question and answer period after our next speaker, which is our last speaker. And he is Peter Kleinhens. Peter is one of Peter's one of Go Sustainable Energy's industrial energy specialists. He has extensive experience in HVAC, compressed air, process cooling, and heating systems. He is technical lead for commissioning and energy auditing services, having audited or commissioned hundreds of industrial and commercial sites. He is also skilled in energy simulation, measurement, and verification, utility data regression, and performing custom tool creation for complex projects. Peter has instructed numerous trainings on energy auditing and M&V techniques. He has co-authored or authored technical papers on topics such as combined heat and power, metering and verification methodologies of compressed air systems, net zero energy, how energy inefficiency outfoxes the mechanisms intended to promote energy efficiency, and skylighting. Those all sound pretty interesting to me. Peter received his bachelor's in 2006 and master's in 2008 degrees in mechanical engineering from the University of Dayton, and is a registered professional engineer. And Peter will be talking to us about third-party measurement and verification as a treasure hunt meant to be shared. So Peter, please share your presentation with us.
Hey everybody, hopefully you can see my screen and hear me talking. Is that correct? At least one person give a thumbs up. Great. Hi, so thanks for listening. So this is third-party M&V is a treasure meant to be shared. And for those who like to look ahead at generally what we'll talk about, here's the rough agenda on the slides we'll be going through. So just to start off by talking a little bit about the authors, how we came to write this paper or why we wrote this paper. So Go Sustainable Energy, we're an energy efficiency consulting company out of Ohio. We provide third-party unbiased information to our clients or serve as an owner's advocate in all the work that we do. So this leads us to providing services like energy audits, commissioning, energy management services, or distributed energy resource analyses. But the focal point of this paper is third-party measurement and verification for energy efficiency programs and energy efficiency program consulting that we also provide. So this paper stems from over, to put it in context, a decade of our work, mostly in Ohio, and it's based on hundreds of different third-party measurement and verification projects that we've conducted. And so we took some time this past year kind of reflecting on the immense knowledge that we've gained and expertise we've built from doing all this measurement and verification. And we started to realize that outside of ourselves, our own company, aside from maybe a program manager or two and a few program evaluators, it's not clear to us that anybody else actually ever sees or accesses all of this wonderful measurement and verification data. So to kind of put that in context a little bit more, first we want to maybe frame up that efficiency program measurement and verification is a unique treasure. Efficiency programs have kind of like unique superpowers to generate all of this third-party measurement and verification data. They have the economic structures and backing to do good measurement and verification. It's hard to imagine it happening outside of an efficiency program. They see high volumes of projects and traverse hard to access facilities. Not just anybody can go knock on the door of a proprietary manufacturing facility and look at all their equipment and install measurement and verification meters. And then on top of that, there's baked into a lot of these programs have to follow high quality standards. You know, whether it's IPMVP is kind of international measurement and verification protocol standards, or in Ohio, where we're from, we had to a lot of times pay real close attention to the regional transmission organizations, PJM Manual 18B, that allows some of the programs. It has to be done at such a criteria that programs could potentially bid some of their savings into the capacity markets. And then on top of that, the energy efficiency programs are seen as sort of a third or unbiased party in a type of a trusted authority. So they do have unique abilities that other institutions, organizations don't have to generate lots of great data. And as these examples are going to show, this data can be very useful to doing more than just quantifying savings and issuing out incentives. So we can only scratch the surface with all the case studies that we have. So just to kind of help illustrate what we're talking about, we'll go through 4 different types that I'll explain each one as we get to it: suspicious efficiency technologies, process-specific technologies, low-hanging fruit projects with hard-to-find real numbers, and emerging technologies. So starting off with suspicious efficiency technologies. These are products and technologies pushed at manufacturers in the name of energy efficiency, but are intentionally or unintentionally misleading. They don't necessarily, the point of the project might not necessarily be energy efficiency savings, for example. One technology that we saw a lot of, especially about a decade ago, at least in our area, and others that have worked in programs have maybe encountered this, is something called reactive power correction units, If you kind of like look up this type of technology online, you'll find lots of aggressive data that has lots of case studies that show really big savings. And it's kind of unclear why it has savings. They're kind of known as power saving boxes, or they reduce power in the lines. And I've seen some really famous case studies where they save 10 to 30%. And it's not even clear if that's kilowatt hours, if that's dollars. And in our area, the program we were working with, it was an aggressive vendor that was pushing it to the point where our program asked us, why don't you go out and actually do the measurement and verification on this project so that we can figure out whether or not it saves energy. And so we had a unique experience that only an efficiency program could probably provide us, where we went to a large plant where they had already invested in these RPC boxes. They had 15 compressors, so it was a large plant, over 1,000 horsepower and compressor. Since manufacturing plants aren't perfect live laboratories, we were able to figure out how we could get really good data from at least 2 compressors without interrupting their production too much. So we were able to, on the right there, you see we could get really accurate, high accuracy metering on the compressor with the RPC active and then with the RPC bypassed. And in each case, we could also then, since RPCs impact power factor, we could measure it with the power factor. Sorry, my doorbell's ringing. This is weird. So we were able to have the RPC bypass, the RPC active, and then we could also have the compressor loaded and then fully unloaded. And to our surprise, we didn't expect to see any savings. We did measure consistently across 2 of them, 1.5% savings. That said, though, we don't necessarily think that this equates to a closed case. There's savings. It's far less than what was expected. And like I said, it's not a laboratory environment. So this manufacturer had spent close to $70,000 on this technology, and there was not much of a payback at all on this technology. And the good news is that the utility program or efficiency program we worked with was able to kind of close the book on this one. And it's worth reflecting, does this data exist without an efficiency program? And who else gets to see this data? To our knowledge, nobody other than the efficiency program and this one particular client. The next type of technology would be process-specific technologies. So these are projects that apply to specific manufacturing processes and shared data that's hard to find. So you could think of like plastic extruder barrel heat controls. That's something that doesn't really, that there's probably thousands of these across the country. So there'd be lots of different peer manufacturers interested in opportunities for this process. We had the luxury to get to study 30 different plastic extruder barrels. And just for people's context, extruder barrels have tight barrel temperatures that need to be required so that the product comes out just right. There's plastic being melted within it. And to maintain that, they have heater bands, electric resistance heater bands, and then they also have to counter that with chilled water. So you get this overheating, overcooling, overheating, overcooling. That's inefficiency. So the more you can smooth out that overheating, overcooling, the better. And that's what this PLC controls upgrade is that we got to see on 30 different barrels in our territory. So this PLC controls upgrade produced a lot of data. So here's like a big ugly table with lots of numbers, but I'll kind of walk through like, so what kind of data is created when you do these measurement and verification projects, aside from the great story on what is the technology, how does it save energy, you also get to define, do we care about the savings? Is it significant? You know, what's the annual kilowatt hour savings and cost savings? In this case, it is. It's worth pursuing further. In addition to that, you get to see a whole slew of implementation costs because you have to make sure the project's above bar. You need to have receipts or pay apps provided. And then on top of that, we can calculate what's the simple payback of each of these different projects. And lastly, you can also evaluate what the different peak demand savings are. In this case, it mattered what the utilities peak demand savings were. And then I was just saying, if they want to bid these savings onto a capacity market, what the PJM capacity savings would be, which they're going to be a little bit different. So reflecting on this case study, I ask you to kind of think about who would care about having all this data. And I would like to think like DOE or national labs, and definitely in particular, any of the plastic extrusion process manufacturers across the country, which there'd be thousands of them. And without seeing real case studies like this, all of these columns are just question marks to them. They might have generic literature, they might have a vendor trying to explain to them that it is a cost-effective project, but here we can actually see what the simple paybacks might be across 30 different projects. And it's not a clear-cut case. Some of them have better paybacks than others. And so we can only scratch the surface, like I was saying, but there's so many process-specific case studies that we wish we could share. And just to kind of illustrate what I'm talking about, all the different wastewater treatment plants across the country, we have lots of case studies on jet aeration being upgraded to fine bubble diffusers, or different silicone producers. It's kind of a niche manufacturing process. We've measured and verified lots of crystal grower upgrades, or swine and piglet production, heat mats versus heat lamps, and lots of different automotive paint process type improvements, to cannabis growing, to injection molding machines. Are hydraulic versus electric injection mold machines better? And not just which one's better, by how much. What's the simple payback? Do you invest in it at the end of life or before then? Stamping processes, so many more. So you kind of get the impression on what kind of data gets generated within an energy efficiency program at a pretty high volume with pretty high quality case studies as the output. The next one I want to talk about is what we call low-hanging fruit with hard to find real numbers. So these are projects that's taken for granted that much of the, it's so taken for granted that it saves energy that measurement and verification is usually not really done, or maybe it's kind of hard to conduct good measurement and verification on the project, and everybody relies on rules of thumb or theoretical numbers for it. One example would be compressed air leaks. So everybody knows that saves energy, everybody likes to do it. We were lucky enough that one of the programs we worked with wanted to develop what they were calling a semi-prescriptive program for compressed air leaks. In other words, what's the fewest amount of inputs we could get to still get a decent savings number for fixing compressed air leaks? And we were lucky enough to find 5 different manufacturing facilities that would let us run some fairly elaborate testing at their facility. And so examples would be, we were able to do multi-week pre and post power metering on the whole compressed air system. We were also able to walk around the facility, validate that the existing leaks did exist and they had all been tagged by the facilities. And then also they maintained a leak repair log that we could also walk around and see that the leaks were fixed. And then on top of that, we were able to we picked these facility specifics such that during non-production hours, they could isolate their system down to just one variable frequency drive compressor to run the whole entire plant. That's one that's much easier to meter and extrapolate what the different flow rates are coming from it. And then we could walk through ensuring that there were indeed no production taking place in the plant. It was all just going to leak. So we did a big plant walkthrough during this time. And then we were able to do, just to make sure and maybe get different kind of numbers for different approach, air bleed down and recharge tests. So you can see on the right there, this was pretty fun, the bleed down test. In blue, that's before they fix the leaks, and red, it's after. It takes a lot longer for the system to bleed down to ambient pressure after you've fixed all the leaks. We were able to verify and quantify that. Same thing with pressure recharge tests. Then once you bring it back up to pressure, the system without the leaks should come up to pressure much quicker. So this is kind of rare data. It's kind of a playground for engineers like me or my peers. And in the end, we got out of these 5 case studies, since we said manufacturers aren't perfect living laboratories necessarily, you can't control everything. 2 of the case studies fell through. The manufacturers sort of failed to meet the leak repair program criteria to actually measure anything. And we saw like no to negative savings. There was a 3rd one, case study 3, kind of mixed results. We did see savings, but it wasn't a perfect experiment the way we'd like it to be. We were lucky enough, and we're thrilled about this. 2 of them were perfect experiments, kind of the way we wanted them to be. And maybe the number that I would look at there, where this is interesting, where these case studies add value, is that, you know, DOE compressed air challenge kind of estimates or indicates that about 30% of compressed air goes to leak loads in an average plant. And so for us, it's fascinating to see. I can't picture anybody getting a more accurate test than we were able to get in this facility on what the leak load was. We saw 53% and 66%, so that's much higher. You know, so we don't have representative sampling to say this is the average or anything like that. But to us, that's fascinating. And there's got to be much more data out there that's still not being shared or thrown into the mix. And if you're a manufacturer thinking about doing a leak repair program, those programs aren't free. Everybody thinks it's low-hanging fruit, but they have to invest a lot of resources. And if you've ever actually watched someone fix a compressed air leak, it is not easy. So they need to know how much is it worth to us. And once you're actually looking at real numbers that they can trust, not just rules of thumb, you can maybe help break down that barrier a little quicker. Here's another quick one that also low cost, no cost. We were lucky enough. We thought this was interesting enough that we had never seen it, and we're guessing many others hadn't. There was a blower that received, it got reshivved. They reduced the V belts from 3 belts to 1 belt. And then on top of that, they upgraded the base of the motor. And from that, you can see there we saw 2.4% energy savings. And what fascinated us is in our data, we looked at it and we're like, wait, what's this? There's another jump that's very clear in energy consumption. It turned out they had cleaned the whole entire fan system out a week later also. So we're sitting on this great data that almost accidentally got generated here. But this is just another lesson to learn that comes from efficiency program M&V. And then the last type we'll talk about is emerging technologies. These are projects where the technology or upgrade is promising, but unfamiliar to the end users. And so the example we'll use is back in 2010, and still to this day, at least in the manufacturers we work with, PSC motors, which is a common type of motor most of us are familiar with, could be upgraded to electrically commutated motors or EC motors. And but this was appropriate for just fractional horsepower motors. EC motors have a much higher efficiency at fraction horsepower loads than PSC motors. And when you go into a large manufacturing facility, the large ones have thousands of these little fractional horsepower motors that run small fans, pumps, compressors. In a lot of the case studies that we got to look at, it was evaporator fans. So if you have process cooling, there's just lots of little evaporator fans like what you see off to the right. So we were lucky enough to observe 471 replacements of PSC motors to EC motors. And of those 71, we were able to do metering on what were the actual savings. Typically, the savings are so small for an individual project like this, people wouldn't really bother to do this type of elaborate testing. So within an energy efficiency program where they're trying to develop guidelines for what a rebate should look like, to them, this is worthwhile to do. And so maybe without focusing too much, there's the numbers that got generated from the 71 M&V projects. Maybe the only thing I'll just point out is on the right side there, the payback back then was a little bit longer than what a lot of manufacturers would like to see. That was 5 to 10 years ago. Nowadays, hopefully the payback's just a little bit better. And in addition to this, in terms of adopting new technologies or making things commonplace, it's really hard to get 71 good case studies for most institutions out there on a new emerging technology. Who would invest in that? In most cases, it's probably left for the vendor or the installation contractors to invest in these type of projects. And then you start introducing, do you trust that data? Is it biased or not? And more valuable data that we weren't able to cover here, but we wish we could. So it could be future papers maybe, or just to help give the idea of what all exists in these energy efficiency programs. Implementation cost data. I know at least our company, for example, we built all kinds of expertise on what things should cost because we were able to look at all this M&V data. We have cool regressions on VFD compressor costs versus size. We know what big compressor projects cost for air controllers or replacements or new dryers, et cetera. We also know a lot of process specific upgrades, things that there's really not a lot of times that you encounter this type of improvement because it's very process specific to this manufacturer. Well, we kind of know what that costs, and we can keep that data in our head. Or HVAC upgrades. And then we also get to archive all the different areas where efficiency goes wrong. We saw lots and lots of wrong applications of VFDs. You can't just install a VFD and that's where the savings are. You have to actually control it to do something. And there's a lot of applications that are not appropriate for VFDs. We have a big archive of what those are. And in a lot of cases, we were forced to actually M&V them, even though we knew there wouldn't be savings. And then we have incorrect staging or sequencing, or you also have situations where new replacements doesn't necessarily equal an efficiency project. Think of electric heat retrofitted to electric heat. For engineers out there, it's going to be the same energy. A reciprocating compressor to a load-unload compressor, not necessarily an energy efficiency improvement, or just getting new switch gear. You get all kinds of applications in for things like that. So conclusions. Can this much data get generated outside of an efficiency program? I think, or we think the answer is no. Efficiency programs have unique superpowers that other institutions don't have. They have the economic funding and justification to come into a facility, which is kind of invasive, and conduct good measurement and verification. They also get to see high volumes of projects traversing hard to access facilities. So like I was saying before, manufacturers are very protective of their intellectual property and processes. So efficiency programs, you get to go into one peer facility. The next day you're walking right into their peer competitor. You have to be appropriate about that, but you can walk in between all these. That's a secret power, or a superpower, as I'd say. You often comply with high quality standards, as we covered. And you're seen as a type of trusted authority. So with great power comes great responsibility, as Spider-Man would say. We all pay into these programs and we reap many benefits like incentives. But sharing the data can be another benefit that we don't see being done in any of the programs that we're working with, at least. So sharing data is another way for programs to impact decisions. Incentives, we all very well know, is one way, but sharing data is another way. And at the end of the day, the end users bear most of the risk of all of these energy efficiency investments. So this data is what helps them remove that risk and maybe pull the trigger on investing in the project to decarbonize their process. This is the last slide. So best practice or next steps. One thing that we noticed working in a couple different programs is one of the programs had a very rigid requirement that we wrote technical memos for all the measurement and verification projects. So we had to organize and document what the results were, our analysis methodology, our assumptions, data, provide photos. What this does, now that we're reflecting back, all of these projects are quickly shareable. So if we're talking about sharing the data, that's a great, easy step maybe to require within programs. It also helps validate that it's peer-reviewed, transparent. And then we'd always share these memos with the end user so they could see good news or bad news. And then sometimes it had to be shared with the vendors as well, so that it can kind of diffuse it if it's bad news. Everybody might get real reactive to that at first, but then once you see a good technical memo that outlines it all, it makes it kind of clear that the efficiency program is a good party in this venture and just trying to be honest. Then next steps, so we would say, is discuss how best to share data, yet keeping confidentiality. With manufacturing, this is a big deal. I was just talking about how you can go into all these competitive manufacturers with each other and see their stuff. Well, there's appropriate ways and inappropriate ways that you would have to share the data amongst them. And then also building on existing infrastructure and work with the existing leaders that are making all kinds of efforts in this. We're not saying this is a novel concept that we have. I think we're just trying to facilitate the conversation. You know, we're all here at ACEEE. We know what ACEEE does. We've worked with Consortium for Energy Efficiency, and we've dug through other databases that do exist, like the California PUCO pair database would be one example of multiple. So that's it. Thank you.
Thank you, Peter. That was very interesting. I can relate to a lot of what you were talking about. In my previous position, we'd be called upon by various vendors with a lot of things that they would like us to buy from them. And sometimes they had found ways of getting sponsorship at higher levels of the company than me, which made telling them that this wasn't a particularly great idea more and more difficult. Okay, we're at our question and answer part of the program. Again, I'd like to thank the three speakers. You all did a wonderful job, and I'm glad that you were here. We have a few questions, but one, Joy, I'd like you to think about and maybe share with us. And as smart manufacturing and on small and medium manufacturers goes, I think a lot of people don't know what they don't know. And therefore, I'm wondering if you could talk just a little bit about maybe what the value of smart manufacturing would be to some of these organizations that don't seem to be embracing it at this point.
That's an excellent question. And I wish I had my panel of experts here to help me with that.
Yeah.
The general idea is, yeah, exactly. We don't know what we don't know. So in a general sense, the idea of getting information at the right time to the right person is thinking about all of those different waste stream issues, right? You don't find out about this device not working effectively until you get, the end of the month. You get something, you're like, wait a minute, why is the electricity so much higher, or why is the water so much higher this month? And you have to go back and figure it out. So having systems in place that are keeping track of that and communicating that is one way of reducing waste. A lot of the issues that we're looking at that they were saying that they wanted was how to even just input data. I think we've all had that experience where, you're in a meeting and people tell you information and where did you put that? And then later you're trying to figure out, how do those forms get filled out? Where is that information going to be? So a lot of it is just making things more streamlined, keeping track of things, being able to communicate those things to the right people at the right time, to the right machines. And I think if we say it at that level, I think a lot of people will understand what that means. But it is a huge, with any of these things, it's a huge step that you have to figure out exactly which of those processes do you want to approach, which things are the highest priority, and how much resources do you have available right now to apply to that, because you always have to be thinking about your return on investment.
Mm-hmm. Yeah, it kind of gets to, I guess, what are your highest priorities? And in some organizations, the highest priority is keeping the customers that they've got happy, and maybe with everything as it is, they're having a hard time doing that. Thank you. Let me pose this question for the entire panel, and anybody that has anything to talk about in regard to it can jump in. Peter, Vestal, or Joy. The question is manufacturing taking a holistic picture at sustainability beyond greenhouse gases, such as the United Nations Sustainable Development Goals, and including water, land use, and social impacts of supply chain? What are you seeing in that area?
I can maybe speak on, we do a lot of work with Ohio Manufacturers Association. We're consultants to them, and they serve over 1,000 different Ohio manufacturers. And maybe my short answer to that would be is at the large international companies or global companies, I'd probably say yes, but there's lots of small to medium industrial facilities where I think that would still be a stretch. I think at least the ones that we're familiar with, they're still looking at decarbonizing. To them is kind of almost a toxic thing to say. You almost have to start with, let's make good investments in energy efficiency would be the foot in the door, and then don't quite ruin the conversation by bringing up complete decarbonization just yet.
Yeah. So from my perspective of working a bit with the electronics sector over the last couple of years is these sustainability standards are fairly comprehensive, looking at end of life, what to do with the packaging that the product comes in. So I think they're making good attempts. Of course, they're all voluntary standards. You know, it's the market leaders that are pursuing this. You know, I guess the jury's still out on whether there's going to be broader market adoption. And, you know, to the extent this is being done in other parts of the manufacturing sector, don't really have a good answer on that.
Yeah. Kind of a follow-up part to that was what kind of harmonization are we needing, or in what areas do we not have harmonization of the standards that companies are using to report their progress toward improved sustainability? Vesla, you might have a little bit more insight on that.
So yeah, well, just within the electronic product sustainability standards, so the harmonization is a goal that uses the term consistency among standards for these product-related sustainability standards. But when it comes to corporate standards, that's a bigger, deeper question that I think there's still a lot of work to be done. I think as Gail Boyd pointed out in his comments in the chat, that there's I'm certainly not the expert on this, but I think there's a lot to be done in that area at the corporate level, because there are different initiatives out there, you know, and different approaches, different levels of rigor. So I think there's definitely work to be done.
There was also some discussion about KPIs and what kind of KPIs would be appropriate for a company, and perhaps how do these KPIs relate to each other. And Gail did share some information about that too. But yes, that's a definite factor. How are you counting what you're counting? There was a question about how smart manufacturing is about overall productivity versus energy efficiency. And Joy, did you want to touch on that just a minute?
Yeah, this is actually a really interesting aspect, because I'm coming at it from the energy efficiency perspective. That's where my background is. But the smart manufacturing is really about improving the productivity and improving the general efficiency of the company. So we find a lot of times if we start talking about energy efficiency, we start losing, they start stop, you know, they don't pay attention anymore. But it is the case that when you actually look at when they're reducing all these other waste streams, all those waste streams have energy embedded in them. And so the end result is that we're saving energy by doing this.
Yeah. Yeah, I support that idea 100%. You know, if you're making something that overworking, over processing, you know, all of that leads to waste of all kind. I think smart manufacturing also has the opportunity to bring something that might sound a little bit more sexy to management of a company as to what they want to embrace. You know, a lot of us have been pushing energy efficiency for a long time, and I think it's sexy enough, but top management is often excited about some other things, and this is a way to bring it in. And at the same time, I think we need to be realistic as well. As since we're energy practitioners, I think we do all recognize that the companies we work with have other priorities as well. And this might not be their highest, although it is gaining traction due to a lot of things happening with the environment. I think we need to keep it balanced. So are there any other questions that people had? I would like to just comment too on a couple of the things. As far as standards, it seems like when standards are being developed, there's a tension between the manufacturers that the standards will apply to, and sometimes those on the committee that want to make the standards perhaps more rigorous, and the manufacturers who would probably be happy with the standards being less rigorous so that they can get all the points rather easily. Vestal, do you have any stories about how you've experienced that?
Yeah, well, there was the process that was happening, you know, 2 years ago, for what was called a common criteria that the Electronics Global Electronics Council was working toward, which basically was shut down. Yeah, the reasoning was, some of the manufacturers weren't happy with the right diversity of stakeholders engaged. But I think a lot of it had to do with we kind of like the status quo. We don't want to move too fast. So there's definitely pushback there that unfortunately does exist.
Mm-hmm. And I think too, you mentioned part of the standard was the beauty of it was it provided action items that a company could take toward satisfying the standard. On the other hand, the companies might think that they're too prescriptive in that they have to do exactly that in order to accomplish what's being asked. So the measurement and verification, that was really good. I had some very, very good experience, not good, but in-depth experience with the power factor correction devices and several salespeople. And what I've concluded is I'm sure from the level of aggressiveness that those people showed, they must have bought franchises into something that they thought was real. And it was clear to me that most of the people selling it to me didn't realize that what they were selling was what it was, and couldn't believe that. I guess they were trying to sell apples as oranges or something like that, and that made it difficult. It also is very interesting. It brings a human perspective into it. Once a person buys into one of these things and installs it, it's probably pretty hard to convince them that it didn't work because they've got a personal bias that, hey, I wasn't fooled. I checked this out, and it can take a real technical expert, and in fact, to actually do it totally appropriate, you'd need laboratory conditions in order to make the before and after comparisons, and that just doesn't exist. So, yeah, I think one of the easiest retrofits I've worked on was lighting. I mean, the lights were on or off. If you had that, you had it pretty well figured out. So, okay, we're running out of time. Let's see, there's one more question. Let me ask this. Any insights on how strategic energy management programs are responding to pushes by large companies who are pushing smart manufacturing down the supply chain? I guess the question is strategic energy management incorporating smart manufacturing in its programming? And I don't know if we've got an SEM expert on the panel here.
I can't help you much on that, but I think there's some discussion next week.
Yeah.
Separate but related workshop happening.
Yeah. Well, we're gonna.
That didn't come up with the small and medium manufacturing. They weren't saying anything about we're getting pressured from other companies. So.
Mm-hmm. Yeah. Yeah, I'm a strong proponent of energy management systems. And one of the things that perhaps the DOE should consider adding to the slide to differentiate that from other management, any other energy savings programs is, I think it moves from the equipment focused to the people focused. And that's really important. And, you talked about VFDs in the measurement and verification running at 100%. A lot of that, maybe some of that occurred because somebody set the thing on bypass versus running it off some control signal. Anyway, so I'd like to suggest that everybody come back then for our next session, which is in about a half an hour, and or join us for the debrief following that session. Well, thank you very much, especially to the presenters and to those of you that participated today. Thank you.
Thank you.
Thanks. Bye.
Bye.